Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. Today we would like to present our group project titled Database Development based on the Redbus platform. Before we start the presentation, let me introduce our group members. I am SUMAIYAH binti SUHAIMI. Next is NURSHAIMA binti MUHAMAD ARJUNAIDI. Then AQILAH binti AZMI. And lastly, SOFIA binti MUHAMAD AMIL. First of all, I will explain the company profile of Redbus. Redbus is the world's largest online bus ticketing platform. It was founded in 2006 in India. The company was established by three founders, which are Panindra Sama, Charan Padramanchu, and Sudhakar Pasupunuri. The platform is available through both a website and a mobile application, which allow users to book bus ticket easily and conveniently. The main purpose of Redbus is to provide a simple and efficient way for customers to search, compare and purchase bus ticket online without needing to go to a physical counter. Because of this digital system, customers can save time and have more flexibility when planning their travel.
Moving on to the problem statements based on the current existing data management. The first one is insufficient insights into monthly ticket sales, which can be challenging to predict demand and optimize service schedules. Online bus ticketing platforms such as Redbus generate large amounts of booking data, but this data is not always analyzed in a way that clearly shows monthly ticket sales trends. Next, lack of analytical focus on determining destination level ticket demand peaks. Identifying destinations with the highest number of ticket bookings is important for route planning and capacity management. However, available Redbus industry reports mainly provide general statistics about passenger volumes without clearly identifying which destinations experience the highest demand peaks. This lack of focus limits the ability of operators to prioritize high demand destinations and improve operational efficiency. The third problem is the lack of analytical framework that aggregate total revenues by destination. Although Redbus collects detailed ticket transaction data, including fare information, current reports usually present revenue figures at an overall or regional level, rather than by individual destination. Without such analytical frameworks, transport operators may find it difficult to assess the financial performance of specific destinations accurately. Lastly, underutilized data sources for quality analysis in bus transport studies. Digital platforms like Redbus collect various types of data such as passenger reviews, ratings and booking records, which can be useful for evaluating service quality. However, many academic studies on bus service quality still rely mainly on surveys and do not fully use these digital data sources. So based on the problems stated earlier, we have came up with 4 objectives for our project, which are to display the number of tickets sold for each month of the year 2025, to find the highest number of tickets booked by destination, to calculate the total sales for each destination, and to display the top 5 highest average bus rating reviews submitted by passengers.
Next, significance. So, this study significance as it provides a clear understanding of sales performance by displaying the number of tickets sold for each month of the year 2025, identifying the destination with the highest number of tickets booked, calculating total sales for each destination, and displaying the top 5 highest average bus rating review submitted by passenger, which improve understanding of sales pattern and customer demand.
So, I'm here to explain about methodology. The bus ticket booking system is developed using the database lifecycle methodology to ensure a structured and reliable database system. The process begins with planning and system definition, where the project scope, objectives, and users, such as passengers and operators, are identified. Next is requirement analysis, which focus on functional requirements like ticket booking, seat selection, payment processing, and review submission. Non-functionality requirements such as performance, data security, and data integrity are also considered. The design phase consists of 3 levels. The conceptual design produces the ERD. The logical design converts entities into normalized relational tables, and the physical design defines data types and storage structure to support efficient transaction processing. The system is then implemented using Oracle database where primary keys and foreign keys enforce relationship and integrity constraint. Finally, during operation and maintenance, the database is continuously monitored, updated, and secured to ensure scalability and long-term reliability. This slide shows the entity relationship diagram for the bus ticket booking system, which illustrates how all entities are connected and how data flows within the system. The passenger entity stores passenger information such as name, age, email, and contact number. A passenger can make multiple bookings, which is represented by the one-to-many relationship between passenger and booking. The booking entity is the central component of the system. It stores booking details such as booking date and booking status, and it links the passenger to a specific route and schedule using foreign keys. The route entity contains journey information including source, destination, distance, and ticket price. Each route can have multiple schedules which are defined in the schedule entity. The scheduler records departure time, arrival time, and travel date for each trip. The bus entity stores details such as bus plate number, bus type, and driver name. Each bus is assigned to a route and is operated by an operator, whose details are stored in the operator entity. Seats within each bus are managed through the seat entity. Since a booking can include multiple seats, the many-to-many relationship between booking and seat is resolved using the booking seat associative entity. The payment entity records payment information for each booking, including payment date, payment method, and payment status, ensuring accurate transaction tracking. Finally, the review entity allows passengers to provide rating and comments for their booking, enabling feedback collection after the trip is completed. Overall, this ERD is designed using normalization principle and primary and foreign keys to maintain data integrity, reduce redundancy, and support efficient database operation.
Next, I will explain the result from Objective 1, which is to display the number of tickets sold for each month in 2025. The results were obtained using SQL query that joins the booking and payment tables, where only successful payments were included to ensure accuracy. The booking date was formatted by month and year, and the total number of tickets sold was calculated for each month and sorted in chronological order. Based on the results shown in the table and bar chart, we can see that some months show higher ticket sales, indicating peak booking periods, while other months record lower sales. Next, result for Objective 2, which is to find the highest number of tickets booked by destination. This result was obtained using an SQL query that joined booking, route, and payment tables, considering only successful payments. The data is grouped by destination, and the total number of bookings is calculated using the count function. The results are then sorted in descending order to show the destination with the highest booking first. Based on the results shown in the table and pie chart, Kuala Lumpur records the highest number of ticket bookings, followed by Kelantan, Alor, Melaka and Terengganu. Next is the result for Objective 3, which is to calculate the total sales for each destination. We use an SQL query that joins three tables, which are booking, route and payment, to combine all the necessary data. Then apply the sum function on ticket price and filter only successful payments so the calculation is accurate. After that, the data is grouped by destination and sorted from the highest to the lowest sales. From the results, Kuala Lumpur record the highest total sales with 900, followed by Kelantan, Alor, Melaka and Terengganu. The pie chart on the right shows the percentage contribute of each destination, where Kuala Lumpur has the largest share. Last result for the objective, which is to display the top 5 highest average bus rating reviews submitted by passengers. We join several tables, which are review, booking, route and bus, so all the related data can be combined. Then use the average function to calculate the average rating and round it to 2 decimal places for better readability. After that, the data is grouped by bus ID, sorted from the highest average rating and limited to only the top 5 buses. From the results, we can see that bus ID 13, 7 and 6 receive a perfect rating of 5, while bus ID 8 and 3 score around 4.29. The bar chart on the right helps visualize the comparison of ratings between these buses.
In conclusion, this study analyzed the ticket sales trend by displaying the number of tickets sold for each month of the year 2025. This study also identified sales patterns and customer demand by calculating the highest number of tickets booked by destination, calculating total sales for each destination, and displaying the top 5 highest average bus rating review submitted by passengers. This finding support effective sales monitoring and business decision making.